Go ahead, please.
Cool. Thanks, Dan. Yes, so to update everyone here, we had a meeting about the sidecar cap, and we decided not to move forward with this cap for Kubernetes 120, and instead to start from scratch and recollect all the use cases and try to see a good design to accommodate them all. So I wanted to ask here in SIG Node if it's okay to merge the pull request with the sidecar cap and mark it as rejected, maybe in the state. And so we start with a different cap with the following work, because I think it will be quite different. And I wanted to ask exactly how to proceed. Like, we created the document and there are some use cases there. I plan to add some more. But is there any established process that is usually used here? Like, should we start creating like pre-proposals in an informal way and discuss them? Who would like to do that? Or yeah, how do you usually do it here in SIG Node?
So we used all those work started from the real use cases. Sidecar container is really complicated topic. It is. We do have real use cases, Istio, and service mesh. We do. I believe last time when we talked, a lot of people expressed that problem it is the sidecar container is too powerful, right? So how we are going to we've been talk about back and forth and even like the change our decision a couple times based on the new either we based on like the sidecar container didn't completely address all the issue is still or services mesh raised. But on the other hand, the sidecar container itself is really powerful. So many people think about it. They could do something, but which also give us concern because how safely we allow other use cases to using and not cause destabilize our system, destabilize Kubernetes. So this is why like for me, this is like one of those most difficult topic we had. So the problem is other use cases unclear. We've been heard many people raise their hands and say, oh, sidecar container we want, especially for the what kind of dependency, what kind of the signal they lead it. So they are lead of the next container start and the sequential next start, or they need the container finish, successfully finish, or they need this container start, but it's ready to serving the real traffic. So all those kind of is unclear. And obviously, people can say that like right now, I don't have use cases, but I can quickly think about there's the cases, signal, different signal we can give. And also some is like it's only at the start of the time, I waiting for signal, or have like the shutdown, I waiting for some signal. Should I shut down my container, this sidecar container, or my sidecar container down, I need to shut down application container. So all those kind of open question. So I think the best, it is just still stick with what kind of the use cases we want to support and lay out those use cases. And then can say that how we are going to sidecar container support that use cases and figure out what is non-goal. And then figure out if that's not non-goal, customer can abusive using sidecar container to enable some non-goal cases. So it's like it's kind of like the things we need to discuss there. So or maybe like even I think the people also touch base in another meeting we had just dedicated for the sidecar container. They also say Istio, the people mentioned that Istio, a lot of issue actually could be addressed by some other way. We don't know, right? So if Istio issue can be addressed another way, what's another way? In that case, still there are people asking for sidecar container. For other use cases, then we need to dig more. What's that real use cases? So I'm sorry, I didn't give you really more like the defined process here, because this is really complicated problem. The problem, so this is why in that meeting I even call that pod the spec version 2. Obviously that's not, we are not really open to do that, but it's to me like that sounds like if we don't do carefully, right? So
let's say we collect all the use cases in this document. Let's assume that that happened. How we should proceed after that? Should we try to form a small group and meet with this small group, or different groups to explore different ideas and then sync between the groups? Or yeah, I don't know. I'm open. What I was thinking is, yeah. No, please.
I just think about this. Sorry, I just think about this is the big problem. I want heard from like the other people's opinion. I personally think, let me share my personal thing. I personally think, well, this is tough problem. We need some like the small, small group, and who interested on this topic, and or do you have some use cases, hopefully sidecar container, or can address this problem, or is there someone from the services mesh and have that obviously understand their use cases and can help move forward. Right. But I want to hear other people's opinion here.
Yeah, I mean, some of the use cases is Seth got enumerated in that issue or the KEP PR, but like being able to start a container that is supposed to stay running before init containers, which was letting init container, basically letting like an ingress or a network proxy container start before the init containers, because the init containers might need network access as well, and you want all network access to go through the proxy. And then another use case that's off the top of my head that I remember was something called, I think it was called critical containers, where it was, if this container dies, that should be considered fatal for other containers in the pod, and they should all be restarted. Those were two that were off the top of my head.
Okay, yeah, the one about init containers, I think it's already there in the doc. The one about the fatal to pod container, I think it's not there, but I'll make sure to add it.
And then another thing that should be captured is like container shutdown order. Right now, we don't have any notion of in what order containers should be shut down. But with this ingress, with the network proxy thing, there should be some way to indicate that it should be shut down last because the other ones depend on it.
Yes, from the use cases that I saw, if you start the containers in one order and you stop them in the reverse order, I think that's always useful. But
yes, just so long as that dependency chain is explicit.
Right. Yeah. Yeah. But do you have in mind some use cases where you want to start the containers in one order and shut them down in another order?
No. I mean, I think it's reasonable to, if the user is able to explicitly define a startup order or dependency, startup dependency between containers, that tearing them down in inverse order, I think that you can make that assumption.
Cool.
I can't think of a use case where that wouldn't be what you want.
Right. So I was planning to, I'll add these use cases to the doc and some more use cases and try to create some pre-proposals. If someone wants to explore different ideas, please just write me on a Slack and we can create a meeting between us and on coordinate, or just go ahead and explore on your own. I think if this makes sense for everyone. Or Dawn, do you think we should do something else?
I think that's good plan.
That's good.
Yeah.
Okay.
So I will summarize what we discussed, and then just like what you suggest, then let's make that rejection. Why we reject the current cap explicit. Then you can start another one. So I just document. So then can you add what's next there also? So then we can close that cap, then move to the new cap, the new doc and the new cap, new process. Is that okay?
Right. Yeah, perfect.
Okay.
Thank
Thanks.
you very much.
Thank you. And sorry, this is a complex problem. Take really forever for us to go through back and forth.
It's expected. It's a complicated problem with a complicated solution. Thank you all for your time.
Thank you. And so let's move to the next topic, and the topology-aware scheduling.
Yes, hi, it's Gergely. So I just wanted to share some use cases for topology-aware scheduling.
Let me grant you. Sorry. You need the screen share, right? So let me give you host, so you can start.
Okay.
Sorry. Yeah.
No worries.
You can go ahead. I think in the future I can give templates. Okay, go ahead, please.
Okay, so use cases for topology-aware scheduling, and I wanted to bring the VRAN user plane use case here. So this is a quite common telecom use case when we are running the VRAN workloads in Kubernetes, and because of the usage profile of VRAN workloads, we need to use the PDK with SLAOV in this context. And for this, we need to allocate both the virtual functions, both the compute resources and the huge pages from the same NUMA node. And also when these containers or pods are rescheduled, we need a robust scheduling because we need time constraints for restarting the pods, because these pods are really like handling critical workload. And if we have a hardware failure, and for example we need to evacuate the hardware, then we have to ensure that these pods are starting for the first time. So that's the first use case. The other use case is related to AI and GPUs. So in this case, we should have the NIC and the GPU and the CPU. Sorry, the NIC and the GPU should be NUMA aligned, but the CPU is not needed to be NUMA aligned. So this somehow indicates that the requirement for NUMA alignment is per resource based. So we should be able to indicate somehow that NUMA alignment is needed per each resource. And we have a third use case, but I would let Swati to describe that. Or I don't know who I did that to. Okay.
Yeah, I'm there. Thanks, Gargi. So the first one is kind of very generic, capturing essentially the problem statement itself. So it's about the scenario where runaway pods are created because the resources cannot be aligned, and the scheduler is topology unaware. In a scenario, it just ends up creating a series of pod which cannot be scheduled on the right node. So that is kind of a high level problem statement. Like the few use cases that Gergi mentioned here, those are uh, use cases coming kind of from customers. So we just want to bring it to the table here and bring it to everyone's notice. And the other reason is that we want to kind of start the conversation in terms of if other people have use cases, we'd be happy if they could just kind of append those use cases here. So we have kind of a stronger case in pushing topology-aware scheduling in Kubernetes.
Any comment? Um,
Just want to
first,
say
yeah. So the other use
thank you,
cases.
John. Oh, sorry. I just wanted to say thank you, George. We also working on this same use cases as you described. Also, guys from Samsung also working on the same telecom use cases. And Byogun Chan this spring had a presentation here in SIG Node meeting about telecom use cases. I think we'll put the link to his presentation into your document, and maybe we will extend your document. So again, thank you very much for interesting use cases.
Thank you. Yes, and I also can add that in the current Linux Foundation technical event, there was a presentation about about the usage of Kubernetes in telecommunications, and the clear trend was that Kubernetes is used in production in telecom networks already, and telecom operators are planning to run more and more network functions on Kubernetes, and this is why we need these features, because currently Kubernetes let's say makes it possible to run signaling core network elements which are pretty much similar to web servers. They are just using a bit more crazy protocols. But if we would like to run user plane elements which are really handling the media streams from the devices, we need to have this kind of real-time features. I can share the results of the Kubernetes intercommunications survey into the minutes. Also, there was a mention in the previous topic about the critical container feature. I was somewhat involved in that, so I can share the cap to the init. Still about the use cases, can we discuss a bit what else is needed for use cases? Should we like polish them more, or is there any aspect what we should highlight in the document? I see now lots of people are looking into it.
Well, I think the starting point could be just reviewing the design and architecture if everyone feels that is able to meet the requirements that they have for their specific use case.
Okay, thank you.
Yeah. Any comments from the community, especially people plan to using this feature and to support the high performance sensitive workload and all those kind of the require of the NUMA binding support here. And so please share your opinion. And so all those use cases listed here, it makes sense to me. And also I saw those requests in the past. And yeah, so any other? The next step is just to incorporate those use cases into the doc, and then we can carry out the discussing review of the architecture and review of the
Thanks, Ron. Sounds good.
Thanks. Alexandra, any comment on this?
Are you asking me or?
Oh yeah, sorry, I thought that maybe you already. We have some because we Intel build the plugin and the scheduling plugin and all these things. I just want to say that do you have any opinion on the use cases and what you are thinking about what's the next step?
Well, as what you already mentioned, the use cases is something what we know about for quite a long time, and we have similar things and similar desires. So the first step what Swati is working on the topology extender plugin for scheduler, it's good step forward, and based on that we will be building on top of it. So I don't see anything needing to comment at the moment. In the long run, Gergely actually mentioned one interesting scenario is what distinguishing between the containers which have alignment to devices, so the one which doesn't really care about the device's alignment, or vice versa, aligning for device but not aligning for CPU and so on. At the moment, I think we don't have neither in topology manager way to specify that, nor in the scheduling primitives or in pod spec to specify interconnect between or dependencies or requirements for the resources. Of course, during development phase, it can be work around it using some kind of annotations, but anyway, it's more complex scenario, and I don't know even if the current topology manager is capable without heavy override to accommodate those scenarios.
I also have one more complicated scenario, especially earlier we are talking about the Sidecar container. So kind of all those resources, we talk about even like the touch base some before, current design is at the pod level. But for the NUMA, especially for NUMA, and to support some high performance sensitive workload. So they maybe have the client container level, and they may have some helper container within of the pods. Majority of the time, there's no problem, but sometimes it is, they may be like the both helper container or application, which is a really performance sensitive workload, share the single node. They may have like the performance impact to that. So I did see that in the past. So I mean, in the Borg environment. So obviously this is too complicated at this moment. I just threw out here, and we are. That's not necessarily should be the first things we need. Initial we need address, but I just want to mention here.
Yeah, and something what I said back in May when I was doing the presentation about our project. So we have scenarios of when application, as you said, like there is a high performance container which require strict alignment for all the resources, and when there is helpers like loggers or something like sidecars which supporting the application. We have with setup of affinity and anti-affinity, where we can say like this is where should be affinity to the device, and this is anti-affinity, move it somewhere as far as possible in the resource topology away from that HPC container. So that's potentially doable. But again, we need to find the way how to bring in the upstream in the pod spec specification, how we are specifying these dependencies of the resources.
Totally, yeah. That's beyond a little bit beyond the scheduling. That's also have to be how we represent, abstract the requirement for such a requirement. So at the API level, so that's another pod spec upgrade enhancement issue. So unless we can figure out that one, then it's just hard for us to talking about how to support those things.
So speaking about the scheduling and actually this resource topic. So one thing which we were discussing together with Alexei and Swati and one Marcus from NFD, the way how we will be exposing the topology and resources available on the node to the CRDs, to the scheduler extension. So practically we come up with a data structure which allows us to describe all kind of zones, all kind of NUMA topologies or CPU topologies or any other resources in generic way. So as soon as we will land, we will have enough information in the scheduler to actually make a decision. So next it will be to change the algorithm of topology manager. So instead of thinking in the NUMA combinations, to actually think about like resource zones combinations and availability of resources in those zones. So we're moving step by small steps into that direction.
Yeah. Any other comment today? And we are looking forward for the design architecture and coming for the NUMA aware scheduling and incorporate those use cases there, and then we can discuss. There's someone share some the technical survey result. Do you want to talk about? Sorry, if anyone interested. So do you want to talk this one? Okay.
Yeah, I think Gergely just spoke through it, and he mentioned that these are some of the findings from a survey of how Kubernetes is now used in telco environment. That's my understanding. If he wants to add and provide more context to it.
It was for me. I had some network instruction I couldn't get. So yes, what I shared is just the presentation which was presented today in the Elephant technical event, and I just wanted to highlight some facts from here. Like the main thing is that out of the 40 telecom operators, 87% is already using Kubernetes. And from these, more than half are using Kubernetes in production. So this really means that telecom operators are using Kubernetes in their networks. And of course, they would like to utilize Kubernetes to run more and more workloads.
Mm-hmm.
So this is why we need these telecom specific features in Kubernetes to support these users, so they don't need to maintain different clusters for the real-time workloads and the non-real-time workloads.
Okay. Yeah, thanks for sharing that slides. Yeah. Okay. Any other topic people want to talk about? And otherwise we call out today. Okay, thanks everyone. That's all for today. And everyone got a little bit more than 20 minutes back to you today. And thank you.
Thank you. Bye-bye.
Bye-bye.
Thank you. Thanks. Bye.